Hi math friends! Today we are starting a new unit in math and it's about geometry, and as you might know, geometry is a study of shapes. So today we're going to be looking at polygons and then later a special type of polygon. But first we need to understand what a polygon is. So all polygons have to have at least 3 sides. They could have more. The sides have to be straight, so no curves. They have to be closed figures, so what that means is all the sides have to be connected. And they also have to be a plane figure, which means they're flat. They're not three-dimensional, such as a cube or a sphere. So let's look at some examples of what polygons are and what are not polygons. So if you look at the left side of the chart here, you notice that all of these figures have at least 3 sides. They're closed and they're flat and they don't have any curves. If you look at the right side of the figures that are not polygons, you're going to notice the circle here has curved sides, as with this and with the heart. The red shape is a cube, and that's 3-dimensional, so that's not a polygon. And this figure down here, these sides are not connected. They're not closed, so that's not a polygon. So today we're going to be looking at polygons that are called quadrilaterals. Quadrilaterals means they have 4 sides, and you might notice the beginning part of that word quad means 4. So you might have heard of a 4-wheeler is a quad. So there's different types of quadrilaterals, and we can name them and identify them based on their attributes. When I say attributes, it means what qualities or what characteristics they have. So let's go ahead and look at a few. We're going to start with a square and a rectangle. So a square and a rectangle are 2 types of quadrilaterals, and they both have 4 right angles. So when we talk about a right angle, we talk about a perfect square corner. If you were to put a piece of paper in there, it would fit perfectly. So here are the 4 right angles on a square, and here they are in a rectangle. Okay, those are 90 degrees. A square and a rectangle also have 2 sets of parallel sides. So let me take a minute and talk about what that word parallel means. Parallel lines are 2 lines that never intersect or never cross. So if you think about a railroad track, there are 2 lines that will go on forever without crossing. So if we go ahead and look at a square, the top side and the bottom side are parallel. They'll never cross. If we look at the other set here, those sides will never cross. So they have 2 sets. Same thing with the rectangle. There's 1 set and there's 2 sets. Okay? Those are 2 attributes they have here, the right angles and the parallel sides. Now also, in a square and a rectangle, the opposite sides are the same length. So what that means is the top side is equal to the bottom side, and the 2 sides are equal. Now, square is special because all of the sides in a square are equal. Let's keep going. A parallelogram and a rhombus are also quadrilaterals. They have 4 sides. But they're a little bit different because they do not have any right angles. So if you go ahead and look at the angles here in a parallelogram and a rhombus, they are not right angles. They're not perfect square corners. You can't fit an edge of a piece of paper in there perfectly. It wouldn't fit. It wouldn't match up. But they do have 2 sets of parallel sides. So again, the top side and the bottom side are parallel. And then those 2 sides are parallel. And same thing with a rhombus. Also, the opposite sides are the same length, but a rhombus, again, is a little bit special because all of the sides in a rhombus are equal, just like a square. The last quadrilateral we're going to look at is a trapezoid. A trapezoid only has 1 set of parallel sides. And if you look here, if we look at the top of the trapezoid and the bottom, those are parallel. They're never going to cross. However, if I look at these sides and if I extend these lines, and I know I'm going to run out of room here, but eventually you can see that those lines will cross. So they are not parallel lines. They're not parallel sides. So only the red is 1 set of parallel sides. So these are some of the quadrilaterals we have looked at today. So as you can see, we have several quadrilaterals in front of us. All of them have 4 sides. So we're going to go ahead and classify them by some of their attributes. So the first attribute we're going to be looking at is the number of sets of parallel sides they have. So they either could have 0 sets, 1 set, or 2 sets. So let's go ahead and look at our first one, and I can see that there are 2 sets of parallel sides here. So I'm going to go ahead and classify that over here. C is looking like a square, and I know a square has 2 sets. H is a rectangle, and I know a rectangle has 2 sets. And it looks like B is also a rectangle, so I'm going to go ahead and put that in the 2 sets as well. Now, if I look at A, I know these lines will intersect, so those are not parallel. I know these lines will intersect, so those are not parallel. So I'm going to go ahead and put that in the 0 sets. Okay, if I look at K, these sides are definitely not parallel, and these aren't either, because these are going to come up, and eventually, if I keep going this way, they're going to cross. So this will be 0 sets of parallel sides. Same thing with D here. You can tell automatically that there's no sets of parallel sides. Then that leaves me with L and E. L looks like a parallelogram, and we know that has 2 sets of parallel sides, so I'm going to put that over here. And E, top and the bottom looks like a set, but if I go like that with the other sides, they will intersect. So now I've classified these quadrilaterals by the sets of the parallel sides. You can also classify quadrilaterals by the type of angles they have. So we're going to be looking at quadrilaterals that have either no right angles or 4 right angles. So if we look at our quadrilaterals again down here, I can see right away that B has those perfect square corners. That looks like a rectangle, as does C, as does H. So I know that they have 4 right angles. And in fact, if I use a right angle tool, which I'm just using an index card, and I match it up to the corner, I can see that that matches perfectly there. So that those all have right angles, 4 right angles. Now if I look at something like A, and I try to match my tool up to A, it doesn't work. So that doesn't have any right angles. So I'm going to put A over here. I'm also going to put K over here. You can see that there's not perfect square corners. D is another example where there's no right angles, as is E, if you look closely. And if I take my tool here, it doesn't match up. And then I does not have those right angles either, and neither does L. So another way we can classify quadrilaterals is a type of angles they have.